Thank you. Hi, I'm Elissa. I'm a PhD student at the University of Maryland, and this is work I did with Michelle Mazurek and John Dickerson. So I'm going to talk today about some empirical work on measuring the rationality of security decisions. So as security researchers and also security software engineers, we spend a lot of time wondering why people just won't behave securely. We want them to enable two-factor authentication or update their computers, and they just seem not to do it, no matter what we tell them. And so there are kind of a couple of theories of security behavior that have emerged. And the primary one is maybe best exemplified by this quote: "The user is going to pay attention to dancing pigs every time over security." So one of the things that makes security an interesting problem is that it's typically a secondary task. No one goes into their Facebook account wanting to do security today or goes into their email wanting to look for spam messages. And from the perspective of security researchers, it often seems like people behave completely irrationally in terms of how they handle security tasks. The dissenting voice actually says that people are rationally ignoring security advice, and they should never do security because the events that we're talking about are so rare that the cost of actually doing the behaviors or listening to the advice outweighs the risks. And Hurley in this argument says that, well, in the US, banks are going to pay you back if you get hacked, so there are actually no losses at all. From other research, we know this isn't quite true. People feel emotionally quite bad when they get hacked. They also have to spend a lot of time getting the bank to pay them back. So there's been a lot of proposals that there's probably some boundedly rational security actor who does some predictable things and tries to be sensitive to risk and cost, but has certain cognitive biases that make them not behave perfectly utility optimally. While people have sort of discussed this imaginary actor, we've never actually proven it. So we have no model of this person, nor do we understand the extent to which they are or not rational. So in this work, we built a behavioral economics-based experimental system in which we want to observe people's security behavior in a controlled, simplified environment to see how rational or irrational it is, and see whether we can also predict what people are going to do. And so in this experimental system that we built, it very simply simulates a bank account. So people have some amount of money we give them in their bank wallet. During their experience with our bank account, they're going to have to make a security choice. In this case, they're going to need to enable or not enable two-factor authentication, where you get the SMS code, which takes you a little bit of time. And we specifically use crowd workers in this work because their time is very closely linked to their wage. So anytime they spend doing two-factor, if it takes them a minute to do two-factor, that's a minute they're not doing another task and not earning money. So they're particularly good for these kinds of experiments. So what did they actually do? We invited them to create an account on our bank.cs website. And prior to creating the account in their IRB form, they were told that we're not going to lie to them. Anything we tell them about the account is true. And if we mention hacking, it's actually a random number generator. We're not going to get attackers to come and hurt their accounts, and it won't affect their Mturk account. OK, so they come and they create an account. They create a password. And then they're told some information. They learn their risk of being hacked in our study. They're told that at the end of the study, they're going to be compensated with the amount of money left in their bank account, and that we've started them out with $5 in the account. And they're going to have to log in every day in order to keep that money. And we want them to have to regularly log in because if they choose to do a security behavior, it needs to be sufficiently annoying, like it would be on a usual account. They're also told that if they get hacked, they're going to lose all the money in the account. And finally, they're told their hack percentage. Studies indicate 20% of users will get hacked. And there's a couple of conditions in here that will vary. The first is that some people might start the study with $1 in their account, and every time they log in, up to once a day, they'll earn an additional $1. So we're looking at traditional endowment effects here to see whether people take more care with accounts that they start with $5 rather than $1. The other thing that we're going to vary is our hack percentage. So they could be assigned to a condition with a 1%, 20%, or 50% risk of hacking, and these were their real risks. These numbers are picked based on some numeracy research that people can distinguish between these values. There's actually not very good literature in security on how likely people are to get hacked, so that's a little up in the air. OK, so once they learn their risk of hacking, they learn about the protection offered by two-factor authentication. So they're invited to decide whether to enable two-factor, and they're told that if they do, it'll protect them from hacking 90% of the time. So they have a 20% risk of hacking, but if they use two-factor, that risk is reduced by 90%. And again, we varied this value between a coin flip and 90%. If they decide to enable two-factor, then they go through the typical process where they get a text message with a code, they have to enter it in our system, and then every time they log in subsequently, they have to go through the same process. And finally, they're going to keep logging into the system every day as they need to retain their money. OK, so what are we measuring? Obviously, we're measuring the security decision they make. We're also measuring their password strength with a neural net password meter. And the reason we care about this is we're curious whether people who are particularly security savvy or security sensitive are more rational or make different kinds of decisions than other people. It's also possible that people might perceive the password strength as protecting their account, even though we didn't tell them it would, and we didn't put this into our random number generator. Additionally, we're going to measure their costs in terms of their sign-up and login times. And we actually measure the amount of the time they spend on two-factor in particular, as well as on the process as a whole, so we can specifically compute two-factor costs. We also give them a survey at the end of the study so that we can measure their sort of general security savviness, as well as their internet skill and their demographics, so we can control for these factors and see whether it matters. So what did we actually have them do? So we invited 150 crowd workers to participate in round 1 of the experiment. So they log in every day for 5 days, earn up to $5. They are randomly assigned to one of 8 conditions, which weren't fully factorial, but gave us some good coverage over the various possible variations. 125 of them finished the experiment, meaning they completed the survey. Then, unbeknownst to them, they took a 5-day break. After that, we invited them to play the game again. We said, OK, thank you for doing our experiment. Now you're going to do the same thing, and you might get new information. The new information is true, so whatever information you had last time, disregard. And 107 people finished round 2. And the reason we had them play again was we were curious if they learned anything from playing the first time, or whether we learned anything about their typical behavior that would help us in our predictions. OK, so first we wanted to model whether or not they did two-factor authentication. And what we found was some typical endowment effects. So people who are in the condition where they started with $5 were more likely to enable two-factor. Also, we see some evidence that they're making sort of reasonable choices in terms of their risks. So if they had a higher risk of being hacked, they're more likely to enable two-factor. If they're told two-factor is more effective, they're more likely to enable it. And we see actually an interaction between the protection and endowment. Once we know some things about them, and once they know some things about us, this gets a little more interesting. So we built 3 different models. In the first model, we predict their round 2 behavior simply as a function of round 1 behavior. And we see that doing that explains 35% of the variance in their behavior. So we have a very strong anchoring effect where people like to stick with what they always do. Then, however, if we add in their round 1 costs, so how long it took them to do our task in round 1, not including two-factor, just how long it took them to use the system, we can explain 52% of the variance. So we've learned something about their costs, and potentially in some cases they have as well. And we're more able to determine what they're going to pick. So basically, if you look at the trend data, people for whom it's harder to use the system, it takes more time, are less likely to enable two-factor. People who are faster at using the system are more likely to do so. Finally, if you include the risk factors again and the endowment condition, we explain more variance.
I have a question. So,
yeah.
What do you mean by you're able to explain 35% of the behavior variance?
Sure, the R-squared for a logistic regression model. Okay. So in general, we observe a lot of anchoring effects, but it also appears that people's behavior are affected in reasonable directions by costs, risks, and again, endowment. So when given the choice, people are leveraging these things in reasonable directions. Well, let's talk about whether they're rational. So for rationality, we're going to define, of course, cost as this wage earning time lost. So the time it took them to do the two-factor part of the sign-up, plus the sum of the time it took them to do all of the two-factor parts of their logins, times a wage estimated from Pew data. Then for the utility, we're going to say this is the amount of money they would save if a hack occurs. And we're going to determine rational two-factor use as them picking a behavior where the utility of their choice is greater than the cost. So if the cost was going to be greater than the utility, then you shouldn't use two-factor, otherwise you should. And in the first round, 48% of people did a strictly rational behavior, whereas in the second round, 56% of them did. And this change was significant. So it seems to us like they get a little bit better at figuring out what they should do.
Did you choose the wage to have this high?
The wage was $4.97 per hour, and that's estimated from Pew's data on how much people earn on MTurk. So it was the same for every worker.
Yeah, no, I understand that.
Sorry.
If you choose it too low, you could show meaningful irrationality.
Yes, absolutely. Yes, so we did a sensitivity analysis, and it was fairly linear on that, so you can kind of pick where the point should be. Yeah. OK, and then we also did logistic regression modeling again, where instead of predicting whether a person picked to use two-factor authentication, we predicted whether or not their choice was rational. And there's more details on this in the paper, but basically in sum, those who are in higher risk conditions are more likely to behave rationally. There were different behaviors that were rational, but they're more likely to do so. We hypothesized this might mean they spend more time thinking about their choice, and we have slight evidence of that in that they spent more time on that page than other users did. The other thing is we observed that people who had higher reported internet skill and sort of security and sensitivity were more rational. And we hypothesized that this may be because they have more experience with these kind of behaviors and are better able to figure out what's appropriate for them in this case. That said, the models that explain rationality are only explaining about 15% of the variance, so R squared around 15, which means that there's a lot more work here to be done in terms of figuring out how to model whether and predict whether someone is going to behave rationally. So as I sort of briefly mentioned, rational behavior, right, differs across users. It's not that it's always rational to use two-factor or always irrational. And that's in part because people have different login times, and also because in the real world, people have different amounts of money in their accounts. So this data on the right comes from Pew and is an estimate of how much people earn on MTurk in a given week. So if we think about them wanting to protect that money, they have different valuations of accounts. And so if we assume that two-factor is only good 50% of the time, and we use the mean cost of two-factor across the population, then for someone who has $741 in their account, it would be rational to use two-factor if you're at a 1.5% risk of hacking. If you had $522, you'd need a 2.2% risk of hacking. But if you had only $52, you'd need a 21% risk of hacking. However, in the real world, security requirements are usually not dynamic like this. So you either have to use two-factor, have a choice, or there isn't the option at all. And so while that doesn't necessarily seem like it would matter so much on an individual user case, if we go ahead and look at the market, we can see this can lead to some significant losses. So these values over here are estimated from Pew. These are made up. And you can imagine that if we had changed them, you would get some different results. But the directionality will be the same. So we again assume two-factor protects 50% of the time. And in this case, we could take the everyone has to be secure approach. So this is the I'm going to make you use two-factor. It's going to happen every time you log in. If I do that, then over 1,000 MTurkers, I'm going to see losses of about $126 from wage earning time wasted on two-factor for people who just didn't necessarily need it. If I take the dissenting view, where no one does any security, then we're going to have losses from hacking, either to the company from paying people back or to the MTurkers. If we somehow get them to behave perfectly, we're going to have some gains. And while this doesn't seem very large on a 1,000 MTurker view, then on the market level, this gets a lot larger, where every week you could have losses or gains in the tens of thousands. Now, obviously, if we change these values, you're going to have different directionality. But from a security viewpoint, this sort of points to maybe we need some future work on how to have more dynamic or more mechanism design-esque security requirements that aren't just you have to use it or don't use it at all. So in summary, we developed this behavioral economics-based sort of online simulation platform for observing security decisions, which will later be expanding to other kinds of security decisions and are very open if there are other types of data people would be interested in collecting. We observed that security actors do appear to be boundedly rational, although they have significant anchoring and endowment effects. And we're driving toward figuring out how to model security rationality. But there's a lot more work needed to get a better model. And this may lead to wanting to look at more parameterized models or something more advanced than what we did here. And finally, we're interested in what rational security requirements would look like, or a less one-size-fits-all approach that incentivizes both firms and users to behave in a way that's synchronous and also rational, not just sort of blindly secure or insecure. Thank you.
Any questions? Yes.
Actually, thanks. Very interesting talk. I'm wondering, most people treat security as something annoying, and if you tell them that it may fail 10% or 50% of the time, it's like, why do I bother with it? So what happens if you tell them with factors, it's 100% of the time? Because that may be more
effective. Yeah, we actually started out telling them that, and when we post-surveyed them, they said they didn't believe us because they were like, yeah, I did that before and my account still got hacked and blah, 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 blah. So they seem wise to this theory. Yeah. Yeah, that actually seemed to work worse sometimes. Yeah, go ahead.
I'm curious what you saw about the passwords and what would be the effect of if you just had that thing, where sometimes you type in a password and it has like just the word red that's like this is bad, and like oh god, go back, type something else until it goes green. Like
yeah, absolutely.
Not even saying anything about like the hacking probabilities, that red versus green signal.
Yes, that's actually another experiment we want to do with the password meters. So we were a little bit surprised to see no effect on behavior from the password strength, although we did see a little, as I said, in rationality. Part of that may be that we didn't explicitly say it would be connected. I think also from looking at the distribution of passwords, it looked very similar to kind of your typical medium value account distribution. So I think people may just be sort of used to doing what they always do, and they did it here, which the anchoring results sort of support, and therefore we couldn't see any nuance because they're just sort of behaving consistent with themselves. I do think the meter thing is interesting, especially because people aren't used to seeing security numerically anyway, so it may be more natural. Yeah.
One question. So did you see, by any chance, any clearly distinct clusters of behavior?
Yeah, so when we had them play round 2, what we saw was that most of the movement was people moving from, who had been in, say, low-risk conditions before and chose not to do two-factor, switching to using two-factor. We saw far fewer people switching from using two-factor back. So it seemed like there was more sort of anchoring around, okay, I'm a person who always does two-factor, than the other way. Other than that, our sample wasn't quite big enough to see anything super distinct.